Hey guys, we are going to be reading today about energy in Earth's atmosphere in the text, pages 36 to 39. So if you want to follow along while we read here, it says, in the deserts of Arizona, summer nights can be chilly. In the morning, the sun is low in the sky and the air is cool. As the sun rises, the temperature increases. By noon, it's quite hot. As you'll learn later in this chapter, heat is a major factor in the weather. The movement of heat in the atmosphere causes temperatures to change, winds to blow, and rain to fall. Energy from the sun. Where does this energy come from? Nearly all the energy in Earth's atmosphere comes from the sun. This energy travels to Earth as electromagnetic waves, a form of energy that can move through the vacuum of a space. Electromagnetic waves are classified according to wavelength or distance between waves. Radiation is the direct transfer of energy by electromagnetic waves. So what they're saying is that all of the energy that comes from us to us from the sun has to travel through the vacuum of space. So any energy we get from the sun does come as electromagnetic waves. Radiation is the direct transfer of energy by electromagnetic waves. So all of the energy that we get from the sun is a form of radiation. What kinds of energy do we receive from the sun? Is all of the energy the same? Most of the energy from the sun travels to Earth in the form of visible light and infrared radiation. A small amount arrives as ultraviolet radiation, what you guys call UV or what gives us a sunburn. You know, visible light is the light that we see, and that includes all of the colors of the spectrum, Roy G. Biv. Infrared radiation is what we feel as heat, and then some of it is that ultraviolet light that can give us sunburns, like we said. And this picture here kind of shows you that you can see it says, as the sun rises, energy in the form of the electromagnetic waves reaches its surface. And here we're seeing a spectrum. So visible light is really a small percentage. It's only about 3% of the amount of energy that we get from the sun. And in there, we have all the colors of the rainbow. And we have that, red, orange, yellow, green, blue, indigo, and violet. And then longer wavelengths are what we feel as heat or infrared radiation. And as the wavelengths get shorter, that's how we get the different colors. And then beyond that, we get ultraviolet radiation. Ultra means beyond. So beyond violet is ultraviolet. Visible light. Visible light includes all of the colors that you see in the rainbow: red, orange, yellow, green, blue, and violet. The different colors are the result of different wavelengths. Red and orange light have the longest wavelengths, as you can see down here, while blue and violet have the shortest wavelengths, as shown in figure 1. There's non-visible radiation that we've talked about, what you can't see. One form of electromagnetic energy, infrared radiation, has wavelengths that are longer than red light. Infrared radiation is not visible but can be felt as heat. The sun also gives off ultraviolet radiation, which is an invisible form of energy with wavelengths that are shorter than violet light. Ultraviolet radiation can cause sunburns. This radiation can also cause skin cancer and eye damage. Here, this diagram here shows us, let me see if I can reduce it, what happens to the energy that we get from the sun, because not all of the energy that we get from the sun makes it all the way to Earth's surface. We're on page 38 now. What you see here is that about 25% of the light that we get is actually reflected back into the atmosphere by the clouds, the dust, and gases. About 50% of it does make its way and is absorbed by Earth's surface. That's the energy that does heat the land and the water. 20% of it, though, is absorbed right by our atmosphere in the troposphere. It's absorbed by the gases and particles. And then the other 5%, once it hits the land, is reflected back to the surface into the atmosphere, mostly off of bodies of water. Now, of that 50% that is absorbed by the surface, that energy then will be radiated back into the atmosphere in the form of heat. And we'll come back and talk about these things as we work through this section. Energy in the atmosphere. Before reaching Earth's surface, sunlight must pass through the atmosphere. The path of the sun's rays is shown in figure 2. Some sunlight is absorbed or reflected by the atmosphere before it can reach the surface. The rest passes through the atmosphere to the surface. Part of the sun's energy is absorbed by the atmosphere. The ozone layer in the stratosphere absorbs most of the ultraviolet radiation, and we had talked about that when we did our unit on the layers of the atmosphere, how the ozone layer does absorb the heat, and that's why that layer is warmer. So the ozone layer in the stratosphere will absorb a lot of that ultraviolet radiation. Water vapor and carbon dioxide absorb some infrared radiation. Clouds, dust, and other gases also absorb energy. Some sunlight is reflected. Clouds act like mirrors, reflecting sunlight back into space. Dust particles and gases in the atmosphere reflect light in all directions in a process called scattering. When you look at the sky, the light that you see has been scattered by gas molecules in the atmosphere. Gas molecules scatter short wavelengths of visible light, which are blue and violet, more than longer wavelengths. That's why the sky looks blue. Scattered light therefore looks bluer than ordinary sunlight, and this is why the daytime sky looks blue. However, when the sun is rising or setting, its light passes through a greater thickness of the atmosphere. It comes at an angle, so it bends a little more. It passes through a greater thickness of the atmosphere than when the sun is higher in the sky. More light from the blue end of the spectrum is removed by the scattering before it reaches your eyes. The remaining light contains mostly red and orange light. The sun looks red, and the clouds around it become very colorful. You can see what's happening here. We've talked about this before. This is going to be talking about the greenhouse effect, which we talked about when we talked about Venus. Energy at Earth's surface. Some of the sun's energy reaches the Earth's surface and is reflected back into the atmosphere. About half of the sun's energy, however, is absorbed by the land and water and changed into heat. When Earth's surface is heated, it radiates most of the energy back into the atmosphere as infrared radiation. So this Earth's surface will get the energy from the sun, it will heat up the Earth, and then that heat will then be radiated or sort of put back into the atmosphere as infrared radiation. As shown in figure 3, much of this infrared radiation cannot travel all the way back through the atmosphere into space, but instead it is absorbed by the water vapor, carbon dioxide, methane, and other gases and particles in the air. The energy from the absorbed radiation heats the gases in the air, and that forms a blanket, or what we sort of refer to as an envelope, around Earth that holds the heat in the atmosphere. The process by which gases hold that heat is called the greenhouse effect. Much like an actual greenhouse with the glass panes will let the light in, it will let the heat in, but it doesn't let the heat escape. Our atmosphere works very much like that. When you get a problem where you have a planet that's very good at maintaining heat, you get a runaway greenhouse effect, and that's what happened on Venus. The greenhouse effect is a natural process that keeps Earth's atmosphere at a temperature that is comfortable for most living things. Over time, the amount of energy absorbed by the atmosphere and Earth's surface is in balance with the amount of energy radiated into space. In this way, Earth's average temperatures remain fairly constant. However, as you will learn later, emissions from human activities may be altering this process. That's the end of page 39. I hope that this helped with your reading.